Hello everyone. In this video I'm going to be going through page 157, numbers 1 to 4, 6 and 7. I'm just going to review here first our vertex form. So the letter A here in front, that is going to be a vertical stretch, and it is also going to flip the graph if it is negative. So if it's positive, it's just going to stay pointing up, but if it's negative, it's going to then point down. The value P is the x coordinate of the vertex, and it is also a horizontal translation, so slide left and right. The Q is the y coordinate of the vertex, and it is a translation up and down, so it is a vertical translation, slides up and down. Okay, so question number 1, it says describe how you can obtain the graph of each function. So we're going to start with this. State the direction of the opening, whether it has a max or a min, and the range for each. And I'm going to do just A here. So the first part was how to get from y equals x squared to y equals 7x squared. So what we want to do is I'm going to write the original function y equals x squared like it was in vertex form. Okay, so what I just did there, I filled in a 0, so I had a 0 in with the x squared. So it's x minus 0 squared, that would just give me the same thing. And then I can add this plus 0 at the end. Again, that won't do anything, so again, it's still the same thing. So these two are equivalent, but then I can see how we went from that to get to this new one now. So all that's happened is that's changed to a 7. So if I was going to describe how we went from this one to this one, this has just changed from a 1 to a 7, and that number there, the A, that was a vertical stretch. So it's been vertically stretched by a factor of 7. Next, it wanted the direction of opening, and since A here is positive, that tells me that the graph is then going to point upwards. So the direction of opening is upwards. If it was negative, it would have pointed downwards. Now, because it points upwards, just like this one right here, if that points upwards, for this next question, if it has a max or a min, that point there is going to be the lowest point. So it's going to have a min value, and that value occurs at whatever the Q point was of the vertex. So it's a min at y equals 0. And then the range is going to be y given that y has to be greater than or equal to, because it has a minimum of 0. And y has to be an element of the real numbers. So our graph was like this. It only went as low as 0, so y has to be greater than or equal to 0. Number 2 says describe how the graphs of the functions in each pair are related, then sketch the graph of each second function in each pair and determine the vertex, the equation for the axis of symmetry, the domain, range, and any intercepts. So just starting over here, how to get this graph from y equals x squared. So again, I'm going to compare the two functions. And the first one, I'm just going to write it in vertex form again. So that's just this one written in vertex style form. And then it changed into this one. So I can see the only thing it did was it went and changed this 0 to a 3. And I knew that that number there, that was going to be my horizontal translation. So all this has done is moved it over 3 units. Okay, and normally it's x minus, so this must have been a minus 3 originally for us to get this plus, because minus minus is a plus. So if we have a minus 3 as our P point, that means we have shifted it 3 units to the left. So it's moved 3 units to the left. Okay, our sketch here we're going to do last. To find the the vertex is going to occur at, from what we had up top, it's going to be -3, and then the Q point was 0. So it happens at P and Q, and that was at -3 and 0. The axis of symmetry happens at the P point, and the P point is just -3, so we got x equals -3. Domain is one of the easier questions for quadratics. It's just always x is an element of the real numbers. The range is going to be y, given that y has to be either above the vertex or below that vertex point. And our graph, because a here was positive, that 1 is positive, that means our graph is going to point upwards. And our lowest point was this q. It only went as low as 0. So y has to be greater than or equal to 0. And y has to be an element of the real numbers. For intercepts, I'm just going to do that over on the side here. So if we wanted to find our x-intercept, that is when y is equal to 0. So I'm going to plug in y equal to 0. So we started with this. And now y changes to 0. Okay, and then we want to solve this. Now I can kind of instinctively look at this and see that I'm going to try to get 0. So if I have something here and I square it, the only way I'm going to get 0 is if this something is 0. 0 squared is 0. So if I put in a -3, -3 plus 3 is 0. And 0 squared is 0. So x is going to equal -3. So that is going to be my x-intercept. Our y-intercept, this occurs when x equals 0. And this is because wherever your y-intercept is on your graph, I'm just going to zoom in and show you guys like on a graph. If it looked like this, the y-intercept would be right here. And that is when, as this is moving over, it's when x is moving over to be 0. So it happens when x is equal to 0. So start with our function, and then change x to be 0. And 0 plus 3 squared is just equal to 9. So our y-intercept is at 0 and 9. X is 0, y is 9. Okay, now that we know all that information, now I'm going to do my sketch because now I have some points to work with. So I know my vertex was at -3 and 0. So let's do that. I'm going to go over to -3, plot a point. Our x-intercept is the exact same point, so we don't need to plot that one. But our y-intercept is at 0 and 9, so let's plot that. I'm going to say that that point is 9 up. And then I'm going to draw my graph. It's going to come down, hit the vertex, come up, and go through my y-intercept. Okay, so that's a rough graph of that function. Number 3 here says describe how to sketch the graph of each function using transformations. And just a special note for this, always do your translations or your slides last. Okay, so do the stretches or the flipping first and then translate or slide last. And we're going to do D. Okay, so in D, I'm just going to write that out over here. Okay, so looking at D, this is the A value. That's going to tell me the vertical stretch. And if it's negative, it's going to flip it. This is the P value. That is my horizontal translation. And then this is the Q value. That is the vertical translation. So always do the slides last. So what we want to do, first thing we're going to do is we're going to do a vertical stretch of 1/8. So 1 over 8, that's going to actually compress it. So it's going to make it kind of shorter looking. And then the negative here is going to flip the graph. So if my graph was originally going upwards like this, we have now flipped it about the x-axis and it's now pointing downwards. Then we can do our translations. So we said we had this 5.6 here, so that is going to slide it or translate it right, 5.6 units. And then the last one, this 13.8, that's going to translate it upwards, 13.8 units. Okay, so these two have to go first. It doesn't matter the order of those two, they could be switched. And then the translations or the slides have to go last, and the order of those don't matter either. In question number 4, it says sketch the graph of each function. Identify the vertex, the axis of symmetry, the direction of opening, the max or min value, domain, range, and any intercepts. So we are going to do A for this one. So I'm just going to write A below down here. Okay, and there is a hidden 1 right there. So now I can see this is my A value, that is my P value, and that is my Q value. So this is A, I'm just going to write it. That's P, that's Q. So the vertex is going to happen at P and Q. So that's going to be at 3 and 9. The axis of symmetry is just at x equals the x point of the vertex, so x equals 3. Okay, and that is because if we had a graph where the vertex was, say, 3 over and 9 up, the axis of symmetry is the line that cuts through the middle of the graph, so it's going to be going through at x equals 3. Okay, the direction of opening for this one, the A value that we had here was -1. So if it's negative, that means it's going to open downwards. The max or min value, well, because it opens downwards, that means we're going to have a maximum point. And that is at the y point of the vertex. So y equals 9. Domain, it's always the same for quadratics. X is an element of the real numbers. Range is y, given that y has to be below that max point. So that's below 9. So y is less than or equal to 9. And y has to be an element of the real numbers. And then the intercepts, I'm going to do this just down below here. It's going to be kind of like we did in number 3. So the x-intercept, again, that's when y equals 0. So let's start with our function. And then plug y to be 0. Okay, and then we'll solve this. So start to try to isolate this x by itself. So I'm going to minus 9 from both sides. So I'm going to get -9 equals negative x minus 3 squared. Then what I can do is I can get rid of this negative here. So I'm going to divide everything by -1. All those negatives are going to cancel. I'm just going to move up. So I got 9 equals x minus 3 squared. Then I can take the square root of both sides to get rid of the square. So square root cancel out. And when we take the square root of 9, we get positive -3. And then solving this, we're going to do one where it's a positive and one where it's a negative. So I'm going to kind of break this apart. I'm going to do one where it is a positive 3, and then one where it is a negative 3. And then in both of those, just add a 3 to both sides. So this one we get 6, so x is 6, and then the other one we get 0. So those are our two x-intercepts. So let's write those back up top here. So that was 0 and 0, and then our other one was at 6 and 0. Remember, for these, the y is 0, so the y has to be 0 in both of these points. Okay, and then lastly, finding the y-intercept. This one's always a little bit easier, so that's when x equals 0. So start with our function, and then the x is going to change into a 0. So simplifying this, we got 0 minus 3, that's just negative 3. Square that, we're going to get positive 9, times by a negative 1, that's going to give us negative 9. And then add 9 to that, our y equals 0. So our y-intercept is at 0 and 0. And these were our x-intercepts. Okay, moving to number 6 now. Number 6 says, for this function, explain how you can identify each of the following without graphing. So without even looking at a graph, we're going to try to come up with these characteristics. So I'm going to write the function just over on the side here. We can use y instead of f of x. They mean the same thing. Okay, and then comparing this with our other form, it was x minus p squared plus q. So I can see the a, the p, and the q. So the p and the q, that's what gives us our vertex. So the vertex is going to be at 15 and negative 100. For the equation of the axis of symmetry, it's always x equals, and then the x point of the vertex, so x equals 15. For the direction of opening, that we get from the a value. If it's positive, it opens up. So in this case, a is positive, a is greater than 0, so therefore it opens upwards. Part D, whether the function has a max or a min value. Well, if it opens upwards, that tells me it has a low point, so it has a min. Okay, and where that occurs at is the y point of the vertex. So that was negative 100. So it's y equals negative 100. Part E, domain and range. So I'm going to just put D for domain. That's the same every single time. And then the range, we'll use R. So that's y given that. And y went only as low as that one point. Everything else was above it. So y has to be greater than or above that point there. It's always the minimum point, which we had was negative 100. Okay, and then last thing, part F, number of x-intercepts. So if we had, I'm just going to do a rough picture here. If we had the vertex at 15 and negative 100, that means we're over 15, and then we're down negative 100. So the vertex is there. And then we said we knew it opened upwards. So I'm just going to draw a graph that opens upwards. I can see how many x-intercepts this has just from this rough sketch. I can see that it crosses here on the x and here on the x-axis as well. So it has two x-intercepts without me even graphing it. Okay, on to the last question. It says, without graphing, identify the location of the vertex and the axis of symmetry, the direction of opening and the maximum or minimum value, the domain, range, number of x-intercepts for each of these functions below, and we are going to do just a. So a, we're going to again try to write this in our vertex form. So that was a times x minus p squared plus q, and ours was this one right here. So I'm going to try to write it in vertex form. Okay, if ever they don't have brackets in with this x, it's because there's kind of a hidden minus 0 in there. So x minus 0, that would just be x, and then x squared, that would give us back the x squared. Okay, and then the number in front, -4, still got that number in front here, and then the q value is q value at the end. Okay, so I can see the a, the p, and the q, so it's very similar to question number 6 now. So the vertex is going to happen at p and q, so that was 0 and 14, p and q. The axis of symmetry is x equals the p point, so x equals 0. Direction of opening, a here is negative, so a is less than 0, a is negative, so therefore it's going to open downward. And because it opens downward for the next question, that means it only goes up till a certain point and then it comes down. So it has a maximum point. So it has a max at the y point of the vertex, so that is 14. The domain, again, same for every single question. Those you shouldn't get wrong. The range is y, given that y is going to be, it's always got to be less than that max point, which was 14. So y is less than or equal to that max point, 14, and y has to be an element of the real numbers. And then the number of x-intercepts, again, I'm just going to draw a little picture to see what's going on. The vertex was at 0 and 14. So I was 0 left or right, and then up 14, so I was way up here. And then the a told me that it pointed downward because it was negative, so it's going to point downwards. So I can see just from this graph, it doesn't have to be super accurate, but I can see it's going to cross twice somewhere down below. So it's going to have 2 x-intercepts.